it's been a long time since my last video, so it's time for a new video. This video is about this tape recorder here. It's an old tape recorder from the 1950s. To be precise, it's from 1953. It's the Hornyphone WM9542A, and this tape recorder is unfortunately broken. So in this video we will try to fix it. The problem is as follows. If you put it into the play position, then the tape is spinning, but there's nothing coming out of the loudspeaker, and it's getting extremely hot on the back right here. So I won't turn it on now to prevent some extra damage caused by turning it on. First I remove the tape which is on here. It is fixed by these two screws right here. And the next step is, of course, open the back. So let's open it up and see what's inside. So here we can see the inside of the recorder. Here we have the power connector. This is the big mains transformer. Here we have the rectifier tube. These are the filtering capacitors. And here we have some resistors and of course loudspeaker motor. And I'm interested in this part here because it was getting really hot at this part here, so there must be something wrong here. Before we start the troubleshooting, I will show you a simplified schematic of the power supply. Here's the simplified schematic, and here we have the power transformer. Then here is the rectifier tube. And after the rectifier tube there are the filtering capacitors, and these capacitors are special capacitors because they are two capacitors in one housing. So here you can see the plus of the capacitors are separate and the ground is one connection. So, and we have two of them, so these are two capacitors. And then we have here series resistors. So they act like a low pass filter if you look carefully, and these arrows which I have drawn here are then connected to the rest of the circuit. So that is the simplified schematic of it, and with this help we will try to troubleshoot it right now. So I expect one of these caps are faulty and therefore they cause a short circuit, and therefore one of these resistors are getting hot. So for example, if this cap here is shorted, then we have ground directly here and we have an extremely high current flowing to these two resistors, and therefore these two resistors are getting extremely hot, and after a while they will get faulty too. So now I will get the whole thing out of its housing to make the troubleshooting and measuring on the parts easier. So for this you have to first unscrew the top handle. So the next step is to put it like this and remove all 4 feeds. And now finally we have to remove the loudspeaker as well. I have noticed that this loudspeaker cable is in here in a quite unhealthy position, so I think this device was opened before and not assembled back together as it should be. So now we can remove the loudspeaker and hopefully we can remove it from its housing to see it in its naked glory. So there we go. Now it's free. And here we can see the inside, and now we are able to troubleshoot it more efficiently. So I think I will start by measuring these parts here with the multimeter. So as you can see, this resistor here was getting extremely hot. So let's measure the resistance from ground, which is here, or ground is also on the capacitors, I think. Yes, it has now about 0 ohms, so this is connected to ground. This one is also connected to ground. So let's measure the resistor here, which is 0.7 ohms on this side, 1.5 kilo ohms. Okay, so it is shorted on this side, so this is the resistor which is shorted right here. So I think one of these 2 caps, whichever is connected to the resistor, have a short in it. So let's check the first one because I can reach the pins. Okay, this is fine. The caps have 2 pins. So this is also fine. So I think the broken one must be this one. I cannot reach it with the multimeter, but I will have to take it out anyway to ensure that this is the capacitor and not something else in the circuit. So to review this, I expect this being the broken capacitor, and this here is the resistor which we have measured before, because we are measuring 0 ohms from here to ground. So this connection here, so here we must have a short in here somewhere, and this short and this capacitor must cause this short. So I have to take out this board now to check it further. So first we have to remove 3 screws. Sorry, you can see it. By the way, be careful with these devices. Even if they are off, the caps can still hold dangerous voltages. Just a side note. And okay. And okay, it's not so easy because I cannot lift it up easily because there are some wires in the way. So I might have to label them and unsolder them before I can lift up the board. So now I've managed to get out both of the capacitors. So this one is the one which I think is working, and this one is the one which I think is broken. It is held into place with this screw like so. So it's onto here and like this, but also this clamp here on top. So we have the capacitor, then this clamp on here, and this screws onto like so into the board. And there are two capacitors in one, like I showed you in the beginning. So these are the two plus poles of the capacitors, of the capacitors, and this is the common ground, plus and ground. So I should put a plus sign onto here. And if we look at the cap and try to measure it now, I have set the multimeter to ohm again. So ground is here, and what have we got on this side? So we have 300 kilo ohms and decreasing, so this does not look so good. And the other side is okay, 0.23 ohms or so. So this is a complete short, so this is broken for sure, so we have to replace this one. And just in case, I will also replace the other one. Here I have a replacement capacitor, which is much smaller, so it has to have the same value. So the value of this one is 50 plus 50 microfarads. You can see here 50 plus 50, which means 50 microfarads in one. So these are the two caps. And here we have the same, it's also 50 plus 50, but it is much smaller in size. So it should be no problem at all to fit it into here. You can buy these capacitors new on eBay. I will put a link into the video description, so you can check that out. And it has also a screw on the bottom and the ground connector. And okay, it does not completely fit into here because it's a little too big. It's almost, but not completely fitting. So I have to either make this thing smaller or make the hole bigger. So let's see. Oh, and if you're curious about the values of this one, if I measure it, so ground comes to the black lead of the multimeter and the plus, and here you can see we have 28 mega ohms and increasing. So this one, and here we have 60 mega ohm and increasing because it is charging, so therefore the resistance is increasing. And this one is for sure working, and if we put it into the capacitance mode, then you can see 54 microfarads on the one side, and on the other side 55 microfarads. So this is good, but it is new, so I have not expect any other than it is good. So okay, but now I have to figure out a way how to mount it onto here. So now I have made the holes bigger using a Dremel. Here you can see them, they are now slightly bigger, so the capacitor must fit into here. So to insert the capacitor, first I put this ground ring on it. Don't forget it, because then you are in trouble afterwards, because you have to assemble it again. And now I put it into here, and I turn it so that the text is readable. And I do the same thing to this. About polarity, these are both plus, so it doesn't matter which you use, it's just important that the housing is ground. So I put this also into here, and hopefully, yes, it does fit. Okay, and now I put the screws back on. So now they are mounted again. So here you can see they are mounted here. I have the ground connector here and the other one is here. So these two ground connectors, and here I have the two capacitor connectors, and all that's left is just to solder it back together. So let's do that. So now I've soldered all the wires of the bottom to the correct place, and now let's continue with the top. So now after reconnecting the wires, I have to screw the board back to its position. So we have this distance pieces right here and the screws. Now after assembling it back together, I will check if the short circuit is now gone. It must be gone because the capacitor is now replaced. So let's see. And we have 3.3 mega ohms here and increasing, so this is fine. So now let's check if it is actually working. So now let's test it. I have hooked it up to the isolation transformer, and I've already loaded a tape which is recorded. So now I turn it on. So the motor starts spinning, maybe you can hear it, and the tubes are heating up, maybe you can see the glow. And after a while I will start the playback. Oh, you can hear something is coming out from the loudspeaker. So let's start the playback. So, as you can hear, it works. We have fixed it. So, now I will put it back together. So, there you have it, back together. Now it's working fine again. So, thanks for watching, bye!